The camera is far away and the board is fuzzy. That's nothing I could do about that on their end, is there?
I didn't know if you could zoom in and all.
Maybe. What if I try?
There you go.
Thanks.
That's what that's what.
Get it closer, I guess. So that way. Okay. How about? Now it's really going to be confusing to look at it because it's backwards.
So I'm kind of confused where you.
That's what I was trying to say. It might be backwards.
Okay, do what?
I'm kind of confused on where you got like the. Like,
These?
yeah.
Okay, so we're looking at change in quantity divided by the sum of the quantities divided by change in price,
All right.
sum of prices, and then you're going to cross multiply. So let's look at each one of these. I hope that's better where they can see that. So from 90 cents down to 80 cents, look at the change in quantity, which is 100. It's going to be 100 for each one of these because it's going down by 100 or going up by 100 every time. So 100 divided by, add the quantities together, 400 plus 900. I mean 400 plus 500, that gives us 900. Divided by 10 cents is the change in price. Add the prices together, 90 cents plus 80 cents is 170. So now do we see that? See where we're getting it now?
Yeah.
See what we're doing? Okay, so cross multiply here, that gives us 170 divided by 90. Again, we're gonna look at this fraction and know that that's elastic. But if you divide that out, did anybody get it divided? You divide that out, it's 1.88 elasticity of demand. So that's, everybody see where we got that? This is, I mean, this is important, this midpoint formula. Okay, so from 80 cents down to 70 cents, we see that again, we've got $100 difference. Change in quantity goes from 500 to 600. So change in quantity is or add the quantities together, 500 and 600 is 1100. Divided by change in price, 10 cents, add the prices together, 150. Again, cross multiply to get your answer, you would end up with 150 divided by 110. This is still going to be elastic, but not as much because again, the numerator is bigger. So 150 divided by 110 is 1.37 elasticity of demand. So we can look at these 2.71 is much more elastic than 1.37. So.
Yeah, I understand.
Okay, all right, good.
I just didn't
Great.
understand where we were getting where like
The numbers.
Yeah,
Okay.
it was a little confusing.
Okay, so change in quantity, add the quantities together, change in price, add the prices together, divided by. And again, you don't have to divide by 2 because you just don't have to. I mean, these are bigger numbers, but we can deal with that. So let's look then at 70 cents down to 60 cents. Again, we've still got a change in quantity of 100 in this case. From 600 to 700 is the quantity demanded, with lowering that price 10 cents more. So we divide that now, adding the quantities together, 1,300 600 plus 700 is 1,300. And then divided by the price, which is change in is 10 cents, add the prices together, 130, cross multiply with this, that gives us 130 divided by 130, so it equals 1. So that's unit elastic. It equals 1, so it's unit elastic. You have the same percentage change in quantity divided by the percentage change in price. So far, we've been elastic and then we're unit elastic, but if you do reach a point where you keep reducing the price, then your elasticity becomes inelastic. So looking from 60 cents down to 50 cents, we have a change in of 100 divided by 1,500. 700 plus 800 is 1,500 divided by a change in price. Add the prices together, 110. 50 cents plus 60 cents is 110. We cross multiply this one, we'll get 110 divided by 151. Or wait, 150. Anyway, so that would be, we know this is going to be less than 1. It's 0.73. So that's inelastic. When we reduced the price further from 60 cents down to 50 cents, it became inelastic, 0.73. And then from 50 cents down to 40 cents, we have a change in quantity is still 100. Add the quantities together, 800 plus 900 is 1,700 divided by a change in price of 10 cents. And then add the prices together, 90 cents. I don't have that one figured. That's what it would be. Yeah, add the price together, 90 cents. So that, yeah, do 90 divided by 170 is 0.53. So that would be more inelastic than this one. 0.73 is and 0.53, that's inelastic, and it's more inelastic. 0.53 is, because the further you get away from one, lower than 1, the more inelastic. Okay, so does this make sense? Now we're just midpoint formulas, just changing quantity divided by add the quantities together, change in price, add the quantities prices together, and work that fraction. You get elastic or inelastic, but there is an easier way to determine elasticity if you have enough information. Total revenue test, price times quantity. We introduced that price times quantity in the chapter on least cost method of production. We looked at price, total revenue minus total cost. So we can get total revenue test is probably easier to do that. So I'll move over to this board. Okay, so we're to do the total revenue on this. All you're taking is the price times quantity. Your price is $1 times 300. The total revenue is 300. So total revenues at each one of these prices. $1, 90 cents, 80, 70 cents, 60, 50, 40. So total revenue for at $1 times 300, we've got total revenues of 300, and we're going to be able to see elasticities with this as well. So 90 cents times 400 is 360. 80 cents times 500 is 400. So what's happening to total revenue so far?
It's going up.
It's going up. So 70 cents times 600 is 420. 60 cents times 700 is also 420. 50 cents times 800 is 400. and 40 cents times 900 is $3.60. So we see that as price decreases, total revenue increases when it's elastic. So they can reduce the price and have more revenues. Unit elastic is from 70 cents down to 60 cents, unit elastic. And, but if, for example, this is a certain product and they reduce the price from 70 cents down to 60 cents and get the same total revenue, it might be a good idea to go ahead and reduce that price. And you get more quantity out there for, so people buy more and tell their friends or whatever about that. And they actually end up eventually selling more. But obviously there's no benefit in reducing the price further because it becomes inelastic and total revenue goes down if you decrease the price beyond a certain amount. So the next slide is really important to be familiar with. Well, okay, maybe it is. See if I can find the right one. I'll just skip over to it. What happens with total revenue? This is an important slide right here to be familiar with. So if elasticity is greater than 1, we have elastic or relatively elastic. Quantity demanded changes by a larger percentage than price. So if we increase the price, we decrease total revenue. Or if you decrease the price, you increase total revenue. If it's elastic, equal to 1, total revenue doesn't change. Unit elastic, inelastic, quantity demanded changes by a smaller percentage than does price, so total revenue increases. If you increase the price, if they increase the price of gas, their revenues go up because we have to buy it anyway. It's inelastic. If they decrease the price, their revenue goes down. So why would they decrease the price beyond a certain amount? If it's inelastic, you don't have to decrease the price. So, but let's look at this. See, there's another example here. Oh, this one. Always in the upper left, we have a more elastic part of the demand curve. It becomes inelastic as you go down in price. But they're saying, what if this is a movie theater, this example? The price is $8, goes down to $7. We can look at the elasticity coefficient, or we can just look at total revenue, what's happening in total revenue. It goes from 8,000 to 14,000 to 18,000 to 20,000. But at $5 and $4, they get the same total revenue from ticket sales. If this is a movie theater, why would they want to go ahead and reduce the price further and still get the same revenue? Yes.
People would be more willing to buy concessions.
That's how movies make money. 80%, about 80% of their revenue comes from concessions, which shouldn't be any surprise when you know what the price of a box of popcorn is in a movie, what, $8 or something like that. So yeah, it might be a good idea to go ahead and do that. Movie theaters used to have a very inelastic demand. You didn't have any choice. If you wanted to watch a first run movie, you had to go to the theater. You couldn't see it anywhere else. But with streaming, and especially now, they're releasing the movie at the same time they're releasing it on streaming. HBO Max has had Cry Macho and a couple of other movies, I think, that came out. Warner Brothers released the movie and the date the same time, released it on HBO Max. So if you had streaming, you could watch it on that. So they're probably, because of streaming and because they were getting so expensive, for years they were just able to increase the prices and it didn't matter. You didn't have any choice if you like movies and want to go. That was the only way to see a first run movie, but that's not the case anymore. I think that movie theaters demand is probably becoming more elastic. They're trying to do a lot of things to get people into movie theaters, serving alcohol, serving food. Some in Dallas have the dinner and movie tables and chairs, and some have these nice seats that are reclining seats and so on. So they're trying to do a lot of things to get people in, but I don't know if, what else they can do besides reduce the price and for people to come in, because I don't think movie theaters, their demand is not as inelastic as it used to be. It used to be much more inelastic. So they make more money on concessions than on getting people to show to in their seats. I mean, those seats or whatever they are, whatever they cost. So, but there again, a more elastic portion is the upper left-hand portion of the demand curve, and then it becomes more inelastic as prices continue to go down. You reach a maximum revenue beyond which the total revenue starts to decline. So that's your rules with elastic and inelastic. When we look at, and again, this is an important slide here, but what causes elasticity? Substitutability. The more substitutes, the demand is more elastic. Obviously, you have a lot of choices. You can go down range line and choose hundreds of things to have for lunch after class. That's pretty more elastic. The proportion of income, the higher proportion of income, the demand is more elastic. And you're going to shop around when you're looking for a car or something, or a computer, a new computer, sorry, or something like that. It's more expensive. It's a bigger part of your income. These pens are my favorite. They're Pentails, and they always write. I find when I have a paper mate, I'm scribbling all the time trying to make it right, and it's not working. They never run out. I lose them before they run out. So I like them, but I can only buy them at Office Depot, and they come in a package of about 7, and the orange is kind of, and yellow are useless because you can't see them. So I don't use that, I throw those away. But I don't know what they cost, $5, $6, $7 a pack, 10. I don't even know. I buy them every 2 years about. So if the price went up 50%, it's not a big portion of my income. I can still afford to eat if I buy the pens. So, I don't pay much attention to that. It's a very small portion of income. Looking for a car or air conditioning system or heating system, then, we're going to be more careful of, what we're spending. Also, luxury versus necessity. Everybody that has a kitchen has salt and pepper in there, right? Right. Those are highly inelastic, very small part of your income. I don't know what those containers of salt cost. We buy them about every 4 years. I think those containers, that little cylinder containers, hardly ever buy them. So they're very inelastic. I mean, they may double, triple in price and you would notice because you buy them so seldom, but everybody has them. There's not really a substitute for salt and pepper. I mean, there are, I guess, but in it sort of, but not really. Most everybody has that available in their kitchen. Probably ketchup, same thing. I mean, probably all got ketchup in the fridge. So luxuries versus necessities, more time available, demand is more elastic. Even with gas prices going up, I mean, if that continues, if we continue to put more regulations on oil and gas, that's going to have an effect of decreasing supply. And then, of course, there's always the supply chain issues. If gas keeps going up, we might adjust. The next car we look at might be more efficient, over time. So over time, demand becomes more elastic. And the more substitutes, the more elastic. Looking back at the total revenue test, this just kind of looks at demand curves. So total revenue test with elastic demand at $2, in this case, a quantity demanded of 10, so that would be total revenue of 20. Reduce the price to $1 and sell 40 units, that would be a total revenue of 40. So obviously they gained more by reducing the price. If it's elastic, reduce the price, get more revenue. And it's a flatter demand curve as well. With inelastic, it's more of a straight demand curve. Let's say at $4, the quantity demanded was 10. So that's the total revenue of 40. And then reduce the price to $1 and there's a quantity demanded of 20. So $20, so they reduce the price, reduce total revenue, that's inelastic. And then with unit elastic, it's the same. If something's $3 and they sell 10, $30 total revenue, reduce the price to $1, sell 30, $30 total revenue, unit elastic equals 1. So no change in total revenue with unit elasticity. So those are important things to remember about elasticity of demand. Let's look at, again, some of the multiple choice questions here on the worksheet. And we could, looking at number 4, stop sharing here. It says compared to the lower right portion, the upper left portion of most demand curves tends to be more elastic. It's just general rule there. And then let's look at number 5. You're given 5 different prices. And quantity demanded. So using the total revenue test, let's see which one is elastic, inelastic. So 11 times 50 is 550. Oops. 9 times 100 is 900. So far they're reducing the price and seeing revenues go up. $7 times 200 is 14. Still reducing the price and seeing revenues go up. So we know this is elastic. 5 times 300 is 1,500. So elasticity here is greater than 1. So all of elasticity greater than 1. So this is elastic total revenue. But from $5 down to $3, total revenue is 1,200. So this is where it becomes inelastic. So what's the answer to that? Number 5. D, from $5 down to $3 is where the demand became price inelastic. So everybody see that? That's just using a total revenue test. That's pretty easy to see. So number 6 says if a business increased the price of its product from $7 to $8, so they're increasing the price and the price elasticity of demand is inelastic, then what they're going to see is total revenues increase. If it's inelastic, increase in the price, increase total revenue, increase in the price of, just think of it when you think just elastic, inelastic, just immediately think of like inelastic gas. I mean, that's just an easy one for all of us because we all have to buy it. We all know that it's pretty inelastic. And they elastic things that have lots of substitutes where you have lots of choices and you don't care what brand batteries you buy. There's all kinds of brands there if you just want it to be cheap. Number 7, if you're a sales manager for a pizza company and you've been informed that the price elasticity of demand is for your most popular pizza is greater than 1, so it's elastic. To increase total revenues, decrease the price of pizza. You'd increase total revenues that way. Of course, we haven't put cost with this yet, and that becomes important in chapter 9. We've got to put cost in there. And total revenue minus total cost equals profit. So, we'll deal with that one. And then let's skip over, we really don't need the rest of these, to number 12, which is a characteristic of a product whose demand is elastic. And that's D, the percentage change in quantity is greater than the percentage change in price. And that's just looking at the percentage. So midpoint formula is important. You don't have to divide by 2. We'll work some more problems with that. But if you are given the percentage, all you have to do is divide the percentage change in quantity by the percentage change in price. That's all you have to do. So we're going to look at Thursday, we'll look at elasticity of supply and some examples and cross elasticity. And then we'll do chapter 7 is pretty short. So we have a worksheet on chapter 7 as well.
Yeah, you actually didn't give me the test.
What?
You didn't give me the test. I did the worksheet we just did as a test and I stressed about it and
And I believe the two gentlemen back here and my partner here at my table don't have it either. So
The test, y'all
Yeah.
take the test?
you didn't hand, you just gave it the worksheet on table, so I took that.
Sorry.
So I didn't know what you wanted me to do. And
Oops.
so,
Y'all
yeah.
need to take the test. Why did somebody say that?
And I don't know, did you get the test? Okay.
I was handing out a lot of things.
I was gonna say
So-
something, but I didn't want to interrupt the class.
It's okay. You can always interrupt me if something's not right. How about, can you come a little early on Thursday?
Yeah.
15 minutes early?
Yeah.
That's fine.
Yeah, I had no idea. I didn't like realize.
I'm sorry.
That's okay.
Having to design this one is just.
So we just need to come early on Thursday.
Yeah, if you just come early on Thursday, I'll just meet you in the plaza.
I was doing that the whole time and I was just like, I don't call learning
We didn't
this.
do this yet. Oh, no, I'm so sorry.
No, you're good. But I'm trying my best to understand this class.
Yeah, you need to do better.
That's all you can do, bro.
That's right.
You have to remember too, this is a quick paced class.
I know, 8 weeks.
Yeah, it goes quick.